A totem pole, or monumental pole, is a tall structure created by the Northwest Coast indigenous peoples that showcase a nation's family or individual's history and displays their right to certain territories, songs, dances, and other aspects of their culture. Totem poles can also be used as memorials and to tell stories. Carved of large, straight red cedar and painted vibrant colors, the totem pole is representative of both coastal indigenous culture and Northwest Coast indigenous art. Animal images on totem poles depict creatures from family crests. These crests are considered the property of specific family lineages and reflect the history of that lineage. Animals commonly represented on the crest include the beaver, bear, wolf, shark, killer whale, raven, eagle, frog, and mosquito. The crest animals represent kinship, group membership, and identity, while the rest of the pole may represent a family's history. Given the following animals, the beaver, shark, killer whale, raven, eagle, frog, and mosquito, how many totem poles are possible if A, you use all of the animals? So there are 7 animals given in this question. If we're arranging all of them, that is 7 factorial, which is equal to 5,040. Part B. If you only use 5 of the animals. So now we have using some of the whole, and that's where we start to use permutations, as we know. So that's 7, because that's our total, permute 5, because that's how many we actually want to arrange. And that's equal to 2,520. Part C. If the beaver must be first. So on our totem pole, the first animal that's on the pole must be the beaver. So if the beaver already has a spot, then the rest of the 6 slots for animals can still be arranged. So that's simply just 6 factorial. So we leave the beaver, already has a spot, and then we count the number of ways we can arrange the rest of the items. And that's 720. Part D. If the beaver must be first and the eagle must be last. So this time we're starting with our beaver at the bottom, our eagles at the top, and then we've got 5 more animals to arrange in here. So just like part C, we're just arranging the rest of the items, so that's 5 factorial, which we know is equal to 120. Part E, and sorry about my spelling mistake, I just noticed that there. So part E, the beaver must be first, the eagle must be last, and you can only use 5 animals. So this time we've got beaver, we've got eagle, and then if we're only using 5 animals, we've already used 1, 2, there's actually only 3 left that we can use. Now, we don't know which 3 have to go here, it's really any 3. So what's happening is we're trying to arrange 3 of the 5 remaining animals from the given list. So anytime we are arranging sum of a total, we know that we're going to take the total. So in our case, it's 5 because 2 of the animals are already used, so 5. And we're permuting 3. So 5 permute 3, which is equal to 60. Part F. How many totem poles are possible if the shark and the killer whale must be separate, so they can't be together? So this is the exact opposite of our last lesson. So the easiest ways to approach these questions are first take your total. So just the number of possible arrangements there are without any restrictions, and then subtract the number of arrangements where the 2 items you want separate are actually together. Because what'll happen is what you'll be left with is the number of ways that they are set. So starting off with the total without any restrictions is 7 factorial, minus the number of ways that the shark and the killer whale can actually be together. If we count the shark and killer whale as 1, we have now 6 items that we're arranging. But of course, we have to figure out the number of ways we can arrange the shark and the killer whale. So it's multiplied by 2 factorial. So it's 7 factorial, subtract 6 factorial times 2 factorial. And you should be able to type all of that into your calculator at once to find that the result is 3,000 3,600. So there's 3,600 different totem poles that are possible with the shark and the killer whale not next to each other. And part G, animals that fly cannot be next to each other. So let's take a look at the animals that we're given. We've got the beaver, shark, killer whale, raven, eagle, frog, and mosquito. So our flying animals include raven, eagle, and mosquito, meaning our non-flying animals are the beaver, shark, killer whale, and frog. So we've got 7 animals total, 4 of which do not fly and 3 of which do. If we need to make sure that all 4 animals that do not fly are not next to each other, the only way to arrange them is as follows. So we start with a non-flying animal, and then the next animal has to be a flying animal, then a non-flying animal, then a flying animal, non-flying, flying, non-flying. And now that we've arranged them like this, we can actually treat them as separate cases. So our non-flying animals and our flying animals. Case 1 will be our non-flying animals. So since we know that there are 4 non-flying animals, that's simply 4 factorial that we're trying to arrange, because essentially they can go in any order as long as they are in these spots. And we know that that's equal to 24. Case 2, with our flying animals, is very similar, except this time we've got 3 flying animals, so that's just simply 3 factorial, which we know is 6. And since both cases exist within one totem pole, we would do 24 multiplied by 6. So case 1 multiplied by case 2. So we find that our answer is 144, meaning that there are 144 possible totem poles that exist given the animals from the question where animals that don't fly are not touching animals that do fly. And of course, members of indigenous communities don't necessarily use combinatorics to determine, possible numbers of totem poles, but I thought that this would be a really fun way to do some combinatorics practice. Now, I don't have any blanket rules for questions with restrictions because they're all different and you need to make sure that you read each question. But with practice, these types of questions will become a lot easier and you're going to start to notice patterns. But here are a couple of tips and tricks that I've picked up along the way. If you're given a question where one item has a specific spot or a specific space, place that item first, then deal with the rest of the items to arrange. If you're given a question where the items must be separate, so the opposite of grouping, do your total minus grouped items. If you're given a question where the question naturally breaks up the groups into cases, so for example, in our case, we had flyers and non-flyers, break those groups up and work with them separately. It'll make it a lot easier, then bring them together. But in general, the most important thing you can do for these types of questions to get better is practice. Good luck, guys.